Hey everyone, welcome back. Today we are tackling one of the most important shifts in the Python ecosystem in the last decade. We are moving away from the messy old school configuration and mastering the pyproject.toml. By the end of this video, you will know how to take any simple script, Python script, and turn it into a professional installable package using modern standard. So let's start from the theory and then we'll go to the coding slowly. Before we look at the solution, let us look at the mesh. If you have ever opened a Python project and seen setup.py, setup.config, and a requirement.txt all fighting for attention, you know the pain. Setup.py was actually executable code, which meant you were essentially running a script just to find out the package name. It was slow, insecure, and honestly a bit of headache. Now let us understand what is pyproject.toml. This is not just a new file, it is standard defined by PEP 518 and 621. Think of it as a manifest. It is declarative, meaning it lists the facts about your project rather running the code. It's the one-step shop for metadata, your build tools, and your linter settings. For the deep dive, so pyproject.toml just consists of 2 to 3 main section. First is build system. So under the build system we have two lines. One is requires, another is build backend. So this is the brain of the file. The requires line tells pip exactly what it needs to build your app, like setup tools or wheel, and it installs them in a tiny isolated bubble. They don't mess with your main system. The build backend is the engine. Because this is standard, we can swap setup tools for poetry or fit just by changing one line of text. It's total flexibility. As just now I told, it has 2 to 3 main sections. So we have covered build system. Next is the project section. So this is a section where we give our app a soul, we name it, version it, and most importantly, we list our dependency here. This effectively replaces requirement.txt. Now, when someone install your package, Python automatically knows it needs to grab libraries like request or each to make it work. Now let us see the magic of CLI commands. So this is actually my favorite part. With project.script, you can create a custom terminal commands. If I want my users to just type run app instead of long python-m command, I define it here. When they install your package, Python creates a shortcut to them automatically. It makes your tool feels like real software. Now this is a additional feature that you can have in your project.toml to centralize your all the tools in one place. Stop littering out root directory with .flacket, pytest.ini and black.toml. Modern Python tools are designed to read directly from the pyproject.toml. You can configure your code formatter, your linter, and your test suite all within one file. It keeps your project clean and your settings centralized. Let's get our hand dirty. We are going to use the SRC layout. This is the industry standard. We will place our code in SRC folder to keep it separate from our config. I am going to show you how to run a readable install with pip install -e. This is a developer superpower. It lets you change your code and see the result instantly without reinstalling. Let's go and open Visual Code Studio. So I have already created a folder here, my Python app demo, and also created a virtual environment. Now let's start with the actual code. We are going to create one SRC folder because I told that we are going to keep our main code in the SRC. So let us go and create. So touch SRC my app. So since we are going to make it as a package, so we need to have init.py. So let's create init.py Then we can go and create touch src my app main.py touch pyproject.toml readme.md. So again we can write touch md. Let's add some actual Python logic. So we will write a simple function in main.py. So let's just write a method def something start, and we can print starting the application, for example. Let's save it. Now let's go to the pyproject.toml. So let's open this pyproject.toml. So as I told you, we will have 2 to 3 sections into this. The main two sections are mandatory. One is build system and other is project. So in order to save the time, I already have it ready. I'll just copy and I'll paste it here. So now we have our pyproject.toml ready. So as you can see, we have added 3 sections mainly. One is build system that has requires and build backend, project that has name, version, and dependency. So since right now we are not using any dependency, we are not added. So if we want to add the dependency later, let's say I want to use request module, I can add it here. And then project.script, that is nothing but the entry point of the main function of the program. So when you run pip install, Python automatically generates a small wrapper script. This means that your user can simply type hello world in the terminal from anywhere, and it will automatically trigger your Python function without them needing to know the file path or even using the Python command. The advantage of this, that Python automatically takes care of operating system as well. It knows whether it is going to be installed in Mac OS or Windows. It will automatically figure it out. You don't need to do anything. Okay, so this tool.setuptools.packages.find, which is the modern replacement for the find packages function we were using in the setup.py. By setting where equal to src, we are giving the build tools a roadmap. We are saying that ignore the root folder and go straight into the src directory to find my actual Python packages. This is the best practice in Python development. It prevents import accidents. You might accidentally run code from your local folder instead of you install the packages, ensuring your testing environment matches what your users will actually experience. And the final step, we are going to install this in editable mode. This tells Python, look at my source folder directly. This way, if we change the code, the app updates instantly. Go ahead and install it in the editable mode. So pip install -e, run the install command. We can check for the entry point. So where this entry point has got created. So let us run which hello world. So you can see it is clearly showing has been created in this particular path. Now when we just run hello world, it is going to call the function method main.py, and because we are saying that is going to start from the main, so it will print, or it will run the method and it shows the output accordingly. So see inside that, if we go to main.py, we told print starting the application, and here it is. We conclude. Let us understand the flow. How does it work as soon as you run the pip install command? So it goes in 5 steps. So first step is discovery. So in this, pip reads pyproject.toml and looks for the build system. As we can see here, under the build system we have the require and the build backend. Next is isolation. So pip creates a tiny temporary folder, kind of virtual environment, sort of virtual environment. Next step is bootstrap. So it install the setup tools and wheel into that temporary folder. Next step is handoff. So pip asks setup tools dot build meta to build the wheel for the project. Next step is installation. Once the wheel is built, pip installs the wheel into the user's actual Python environment and deletes the temporary folder. Thank you for watching. If you have any question, drop them in comment below. Please like, share and subscribe so that it will motivate me to make many more videos. Thank you.